So, trig review. So, number 1 says find all 6 trig ratios. So to be a ratio, we need fractions. So before we do anything, let's just look at the triangle. Here's theta. This would be my opposite, adjacent, and my hypotenuse, okay? So the first 3 are pretty easy. I mean, we're just going to use the right triangle trig stuff, which is up there. Sine is opposite over hypotenuse, so the answer is just 3/5. That's it. Easy. Okay, number 2, cosine is adjacent over hypotenuse, so it's just 4/5. That's it.
Is that going to be our test?
Yeah. Yeah, you got 6 easy ones for the beginning, okay? Tangent is opposite over adjacent, which is just 3/4. Now, cosecant is the opposite sine, so it's really hypotenuse over opposite, which is just, he's right, totally right. Juan said 5/3, it's just 5/3. It's the opposite of sine. That's all it is. Cosecant is the opposite sine, so it's 5/3. Secant is the opposite cosine, because it's the hypotenuse over the adjacent, so it's going to be just the 5/4. That's all. Cotangent's the opposite of tangent. It's going to be the adjacent over the opposite, or it's just going to be 4/3. Okay, there's the first 6 questions tomorrow. Should be easy. Everybody should get the first 6 questions right, unless you weren't paying attention. Okay, all right. Number 7, change 240 degrees to radians. Okay, so now they're over there on the board. We've got the degrees to radians. It's in orange. We want to go from degrees to radians. So I see the second one says degrees to radians. So we use this formula, d/180 pi. Okay, so that's the formula we want. So 240 is my degree. I'm just going to put 240 here. So I go 240/180 pi. And I should reduce this fraction, okay? So if I reduce it, I get 24/18. Divide both by 6, and I get 4/3, so I get 4 pi thirds. Now, let's say you can't do fractions. I just reduced it. Let's say you can't do fractions. Well, your calculator can. So if you want to do fractions on your calculator, I'll show you how to do it. Don't put the pi in. Don't put the pi. Just go 240 divided by 180, okay? That's a fraction, but let's, in the math button, there's a fraction button, okay? So my calculator is going to change this fraction and keep it as a fraction, 4 pi thirds. There's 4/3, same thing, okay? Don't forget the pi, so 4 pi thirds, okay? Easy. I just reduced. 24/180 is 4/3. So I did. That would be radians, yeah. Right, but tomorrow it won't be. Great question. Yes, I would go straight to it. If it's on the unit circle, you're right, Juan. Okay, 8. We're going to go from radians to degrees. So take a look at the what's up on orange. Radians to degrees, we're going to go 180 over pi times my radians. That's the formula we want. So I'll put my 7 pi 12ths right there. So I'll go 180 over pi times my 7 pi 12ths, okay? Alright, this gets pretty easy. We'll cancel out the pi's, right? Cancel pi's, and I'm just going to go, okay, what is 180 times 7 divided by 12, right? There you go, 180, because I canceled the pi's, right? So I'm just going 180 times 7 divided by 12, 105. So it's a 105 degree angle. 105 degrees, okay? So I'm just using the formula. Cancel the pi's. Then I went 180 times 7 divided by 12. That's what my calculator gave me, okay? Okay, number 9, draw a 440 degree angle. Well, 440, so I do know that if I go all the way around the circle, I'm 360, right? So I'm going to go 360 plus a little bit more. So to find out what's left over, let's just subtract 360 and find out what's left over, okay? So what is 440 minus 360? I get 80. So really a 440 degree angle is the same thing as an 80. So let's draw that. Protractor, zero it out. 80 degrees is right about there. Okay, 80, right? So I'm going to go ahead and draw that. All right. So I'm going to make my 80-degree angle. So I want you to do this. I want you to draw the angle and put 80. Okay, I need both. Okay, draw the angle, put the 80 in there. Okay, that should be easy. Easy, squeezy, lemon peasy, right? So to go 440, I go all the way around 360 plus 80 more. That's all I did. Okay, number 9. It says unit circle. So I'm going to use my unit circle, right? Sorry about that. Sine is the y value. Sine is the y. So let's go to 225. 225 on the unit circle. Let's see. There it is, way down at the bottom. And I want the y value. So the point I see is negative square root of 2 over 2. Negative, so I'm going to have just a negative square root of 2 over 2. Okay, you guys want to see it? Okay, here it is. 225. Here's my point, x, y, my y value, right? Okay, I'll move it up. Yeah, thank you. You guys got to let me know. I'll move it up, okay? Cosine is the x. So 11 pi 6, there it is, at about 330 degrees. Yeah, it's just square root of 3 over 2. And again, I'll point to it if you don't see it. Okay. 11 pi 6 is here. Here's my point, x, y. 6 value because it's cosine, so it's just square root of 3 over 2. Okay. All right. Sine is the y value again. Yeah, negative 30. Yes, totally right. Negative 30, we put them on here. Negative 30 is right there. I want the y value, which is negative 1/2. Good job, Alondra. Okay, so I got negative 1/2 for my answer. Okay. Thumbs up. Everybody good on unit circle?
Yeah.
Okay. Sine of pi. Okay. So pi, find pi and find the y value.
0.
Everybody agree to 0? Tangent of 270. Tangent's my pink ones on the outside, and it is undefined. So you go to 270. You see this little symbol, but that little symbol means undefined. It's where you divide by 0, and you can't divide by 0, okay? Tangent of 480. So tangent of 480 is going around the circle once, and then a little more, right? Alondra?
No, we can do like 480 minus 360.
That's exactly what I'm going to do. You are so right. That's what I'm going to do. Thank you, Alondra. Totally right. So if I subtract it, because I'm going to go all the way to 360, and then what's left over is 120. So I really want tangent of 120. Okay, 120. It's up there. I want the tangent, which is in pink. Negative square root of 3, okay? Easy, right? Everybody's going to be fine on the unit circle? Thumbs up? Okay. So this first page is pretty easy for you. You guys agree?
Yes.
All right. Ready to turn the page? All right, turn the page. All right, now, this little symbol means we're going to find an angle. Okay, we've got to find the angle, and we're going to find the degrees. Okay, that little symbol right there. Yeah. Okay, oops, you can't see it. Okay, this little -1 symbol means we're going to find an angle. Okay, we're going to find the angle. So cosine's the x value, okay? So let's find an x value of negative square root of 2 over 2. So let's see. Negative square root of 2, x value. Okay, x value. See my x values? Negative square root of 2 over 2 is right there. What's my angle? 135 degrees. Okay, there's my, yeah, there is another one. And the other one is, down here. Well, which one's closer?
The closest one is
It's the 135, right? So my angle, theta, is 135 degrees. Okay, theta is 135 degrees. Okay, sine is the y value, so I'm looking for square root of 3 over 2 on my unit circle. So for y value, let's see, y is right here. And it's also here, but this one's closer at 60 degrees, right?
closer to what?
Huh?
Closer to what? 0.
Closer to 0. Closer to 0. So you start at 0 and you rotate up, right? You don't want to rotate further, right? Always one close to 0, so it's just 60 degrees, okay? So theta is 60 degrees. Okay? Tangent, -1. Tangent's the pink ones on the outside.
130.
Yeah, totally right, Grace. It's here, and it's here, right? But believe it or not, this one's closer. Because I can go backwards to it, can't I? So it's going to be a -45 degrees. Yeah.
But wasn't it for the last one -30?
If this, Alex, if this had a negative square root of 3 over 2, I'd say yes, but it's not. It's positive, right? Yeah. Do you want me to show you that? That's a negative 45. Okay, hold on, Alex. You got it? If that were a negative value, I'd say yeah, but it's not. Okay. How am I doing? Thumbs up?
Yes.
Unit circle's easy, right? All right, let's go back to the law of sines and the law of cosines, all right? All right, number 19. I have a pair of opposites. I have an angle and I have an opposite side, right, Hayden?
Right.
I have a 12. I could find angle I. I have a pair of opposites, right? So I need to find an angle. Find angle. I'm going to use the law of sines right here. So I'll go sine of theta. So I can go sine, and I like to put what I don't know first. You don't have to, but I like to write down. In fact, I might just do this on a separate sheet of paper so I got more room to work. Okay, let me redraw it. It's just gonna run out of room. P, G, I, 54, 10, and 12. How's that? So here's my opposites, right? So when I do it, I write down what I want to find first. So I'm going to go sine of I first over its opposite side, which is 12, equals the sine of 54 over 10. Okay, sine of an angle over its opposite side, sine of an angle over its opposite side. Okay, multiply by the 12, right? Multiply up to 12, so my calculator.
76.
Yeah, you probably had me, aren't you, Grace? Okay, so my calculator, I'm just going to go 12, sine of 54, close the parentheses, divided by 10. Okay, and then I get a decimal. Thanks, Josie. So now, that's not the angle, because I need to sine inverse that answer. So about 76.1. That's right, Grace. Nice job. 76.1. Okay. Now, that's easy, but angle G is even easier because in a triangle, the angles add up to 180 degrees. So I'm going to go angle G is equal to 180 minus my 54 plus my 76.1. Gotta just do that, right? 180 minus my 54 plus my 76.1, and I get a 49.9. Okay? Now I've got one last thing to find. Grace, question.
If something were 15 for that, would that still be okay?
Yeah, that's close enough. Yeah. So let's find little g again. I have my opposites. Okay. Write down what you don't know first. I want to find g. So write g down first. So I'm going to go little g over the sine of 49.9. You don't have to, but for me it's easier if I write down what I don't know first. It sets it up. Equals, Garrett, how you doing?
Great.
Equals, I'm good, 10 over the sine of 54. Okay. Okay. I'm going to multiply this up here. So in my calculator, we'll just go 10 times the sine of 49.9, whoops, 9, close the parentheses, divided by sine of 54, and I get about 9.45. 9.45. Okay? How's that? Tavio says good. Everybody else, thumbs up. You're getting better with this stuff, aren't you? I hope. All right. Okay, let's do number 20. So number 20, I will just draw a picture because I need room to work. Okay, here it is. Okay. Chris, it's your job to tell me if I'm off or not, okay? Because you're way in the back, all right? S-A-M, triangle Sam, 8, 69 degrees, and 13. Okay, what do I know? Side, angle, side, right? I know side, angle, side. So that means I could find little s, that's the opposite side, little s. Looks like a 5, so now it looks like an s. So, side, angle, side. Do you know side, angle, side? There it is. Law of cosine. So I'm going to go opposite squared, which is little s squared equals adjacent squared plus adjacent squared minus 2 times the adjacent times the cosine of 69 degrees. I'm just going to use my calculator, right? Okay, so I'm just going to go 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 69, and I get about 158. That's s squared, right? So I got s squared is about 158, so I'm going to square root that answer, right? I get about 12.6. Okay, now I have my opposites, right? So once I have my opposites, I can go back to the law of sine. It's a little bit easier. So it doesn't matter. I can either find little angle A or angle M. Doesn't matter. Grace, what do you want? Angle A or angle M? Doesn't matter to me. A? You want A? Okay, good. So if you do A, write down what you want to know first. So we're going to go sine of A, because that's what I want to find, over 13, over its opposite side. Sine of A over 13 equals sine of 69 over 12.6, okay? So sine of an angle over its opposite side equals sine of an angle over its opposite side, okay? Multiply up to 13. Okay, I'm just going to go then 13 sine 69 divided by 12.6. And I get a decimal. Yeah, because I'm going to sine inverse it, right? Okay, so I'm going to go sine inverse that answer. And I get a 74.4. So angle A is a 74.4, okay? Okay, lastly, angle M. Well, that's easy, right? Add them up and subtract from 180, right? It's just a triangle, so to get angle M. Alondra, I think you're going to do great on this. Yeah, plus 74.4. You got the unit circle down, don't you? So I'm just going to go 180 minus 69 plus 74.4, and I get an answer about 36.6, okay? Okay. Thumbs up. Can you guys do this one? Alright. Okay. Let's look at number 21, okay? Yeah, Micaiah? Do you want this? Yes, always. Say that again.
To find the angle, you do the sine inverse.
Yes, or believe it or not, cosine inverse too. Or you can even do tangent inverse, but anytime you want an angle, you have to use the inverse. Okay, great question. Okay, want an angle? Push the blue button, okay? All right, 21. Always, okay? Always, Micaiah. 21, okay, let's solve. It doesn't say solve. We're actually going to solve this one. And it does say solve it. On the test, it says solve. So I've got 51, 48, 39, and triangle B, E, N. Okay, what do we know? Side, 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 right? So we know side, side, side. We're going to use this one right here. So pick an angle to solve for. I don't know. All right. N. I'm going to pick N. I always like to pick the biggest angle. You don't have to. I just always pick the biggest angle. It's the biggest angle because it's opposite the biggest side. Does that make sense? Okay. So I'm going to go cosine of N equals parentheses. These two are my adjacent sides. That's my opposite. 48 squared plus 39 squared minus 51 squared parentheses. Divided by parentheses 2 times 48 times 39. Okay? Alright, I'm going to go then parentheses. You have to use parentheses. Don't forget your parentheses. Here we go. Got it. Yeah, you bet. So 48 squared plus 39 squared minus 51 squared divided by parentheses 2 times 48 times 39 parentheses, okay? So I get a decimal, and if I got to find an angle, what am I going to push, Micaiah?
Sine inverse.
But not sine this time, but cosine inverse, right? Okay, so cosine inverse, and I get an angle of about 70.9. So angle N is about 70.9 degrees. Okay? Okay, question. Here's my calculator, okay? No, that's okay. I want you to see it. I want you to get it right. Okay. Now, if this is 70.9. Now, hey, there's two choices. It's kind of fun because this morning I was helping Hayden, and at this point we have opposites, but you could do the log cosines again. Hayden said, hey, I got this one down. Let's do the log cosines again. What do you want, log cosines or log sines? Okay. I don't know. Log sines is easier, but I'll do the log cosines, okay? So how about angle E? I know. Tells us why. Just do the log sines is easier, right? How about log sines then, okay?
It's just the area.
It's easy. Okay, I'll do log sines. So we'll go sine of E over its opposite side, right? Equals sine of 70.9 over 51, okay? Oh, there we go, okay. And I can't really zoom it out. There it is. Okay, so I did use the law of sines because it's easier. But you could do the law of cosines all over again. So I did my opposites, right? Sine of E over 48, sine of 70.9 over 51. Multiply that up. So I'll go, let's see, squeeze that in over there. Clear. I'll go 48 times the sine of 70.9, close parentheses, divided by 51. And I need the angle, so Micaiah, what am I going to push?
Sine inverse.
Yes, totally right. Sine inverse of that answer. And I get about a 62.8 degrees. 62.8. Okay, then to find the last angle, angle B.
I don't know why he's doing that, but that's okay. Because it's just the area.
Yeah, we only needed one angle.
No, you weren't listening. It's okay. So I said I forgot to write solve this
we need to do
triangle. Yes. Yes. And you will tomorrow, okay?
Okay.
Okay. It's all right. You weren't listening. It's okay. It doesn't matter. Okay. Okay. Now, finally, how about angle B? How do you find angle B?
It's point there, then try.
Add them up. Subtract from 180, right?
Yeah.
So, angle B, 180 degrees in a triangle, right? I don't know. Let's see what I get on that one. There we go. So, I'm going to go 180 minus 62.8 plus my 70.9, and I get an answer of, oops, back up, about 46.3. Yeah, Talis, I'm sorry. So I forgot to solve the triangle because we're going to have to do that tomorrow, okay? Now, finally, last but not least, let's find the area of this thing, okay? How about the area? Well, I'm going to go 1/2 adjacent times the sine of an angle, okay? So, all right, I can't really zoom this thing out while I'm recording, but, all right. Let's use this angle N, okay? So I got adjacent. There's my two adjacents. There's my angle. So I'm going to go, all right, I'm going to go 1/2 times 48 times 39 times the sine of 70.9. And I'm just going to use my calculator, right? I'm going to go 0.5. Clear that out. I'm going to go 0.5 times 48 times 39 times the sine of 70.9, and I get an answer of about 884.5. Okay. All right. Good. Thumbs up. All right. Let's go ahead and last problem. 884.5. Okay. Okay, last problem. Two ships. Okay. Two ships leave port at the same time. Ship A travels on a bearing of north 35 east at a speed of 10 knots. Ship B travels on a bearing of south 10 degrees east at a speed of 12 knots. Okay, so first of all, let's think about what's going on. This one's kind of going northeast. This one's kind of going southeast. So when I draw port, I'm going to put port way over here on my paper. I'm going to put port right about here, okay? There's my port. All right? And I'm going to draw in a little compass rose. Thank you. Okay. And north is 0, right? Okay, here's my port. And I'm going to need to come up with, now if I want, everybody watch, north 35 degrees east. So you face north. Watch my pencil. Face north and then turn 35 degrees towards the east. Okay, face north and turn 35 degrees towards the east. Does that make sense? Look north and then rotate 35 degrees towards the east. That's how I'm going to do it. So I'm going to north it out. North is at 0, right? 0 degrees. And I'll go 35. 10, 20, 35, okay? And I need to draw this 10, right? I'm just going to draw it big and to the scale. So I'm going to draw this 10, okay? So it's going to go 0 to 10. Okay, there's 10. Okay. This is 35 degrees, which makes this 55 degrees, okay? I'll let you catch up, okay? So I've got my port. That's a 35 degree angle. And I drew this 10 centimeters, okay? Then I'm going to go south 10 east, right? Am I going too fast?
No.
So I'm going to look south. So 0 out, south is 0, right? So I got 0 at south. And I'm going to rotate just 10 degrees towards the east. So I'm going to rotate 10 degrees towards the east, right? Here's south, 10 degrees towards the east, right? And I'm going to draw that 12, okay? All right. I'm going to give this to you when I'm done, okay? So this one's going to be, I say 12, is that right?
Yes.
Way down there, okay? Can you see it? Yeah. So this is 10 degrees, which makes this 80 degrees, and this is 12, okay? How's that? Let's see, I'll just give you one when I'm done, okay? Yeah, 10 degrees. So 10 goes right here. 10 degrees goes there, which makes that 80, right? Because you got to make 90 degrees. So I put my 10 degrees there, and I put 80 there. Okay? So this entire central angle is 135 degrees, okay? All right, how far apart are they? Well, I'm going to draw the line in between them. So I'm going to draw right in between them. Yeah, but we'll sure. Yeah, I would. I mean, obviously I made this too big, didn't I, Londra? I would scale it way down, wouldn't I? Probably should have drawn it half as big. All right. All right, let's see. There's my picture. Call that C. What do I know? Side, angle, side. But wait a minute. They're going to go for 2 hours. We're going to go for 2 hours. So this is going to be 20. And this is going to be 24, right? We're going to go for 2 hours, right? So let's take a trip for a 2-hour trip, huh? Okay, now, law of cosines. C squared equals 20 squared, that's adjacent squared, plus 24 squared, that's adjacent, minus 2 times 20 times 24 times the cosine of 135 degrees. Yes, I will. There you go. Well, I know side angle side, right? I know side angle side, so I'm using that one right there. I'm going opposite squared equals adjacent squared plus adjacent squared times 2 times adjacent cosine of the angle, okay? All right, let's type that in my calculator, see what I get, huh? All right. 20, whoop, turn on, clear. 20